This is Dr. John Bergdorf. The fundamental theorem of arithmetic says that any composite number, that is a natural number that's not a prime number, that any composite number can be written as a product of prime numbers in one and only one way, in a unique way, except for the order of the prime factors. That doesn't matter. So any composite number has a unique prime factorization, a unique factorization into prime numbers. In this video, we're going to explore two ways to figure out what that prime factorization is. So we're going to take the number 120 as an example, and I want to show you two methods you could use to attempt to factor that into primes. One method is called a factor tree, using green for tree. Isn't that cute? And the way this works is this. You take the number you're interested in and you just ask yourself, can I think of any two numbers that multiply together to give me 120? Any two. Doesn't matter what they are. They don't have to be prime, just any two. So when I see 120, I immediately think of 12 times 10. And then I ask myself, the two numbers I got, can I write them as a product of two numbers? Can I factor 12? Can I write 12 as a product of two numbers? And yeah, in fact, there's more than one way to do it. I could think of it as 3 times 4. And I can think of the 10 as 2 times 5. Now what you do is you continue this tree until all the numbers at the ends of the branches of the tree, think of them as the leaves, and you continue until all of those numbers are themselves prime. So for example, 3 is prime, and but 4 is not. 4 will factor again into 2 times 2. 2 is prime, 5 is prime. So if you look at the leaves at the end of the tree, at the end of the branches of the tree, they are all prime numbers. And the factorization of 120 is just the product of the leaves at the ends of the tree, at the ends of the branches. So I'm going to refer to these as the leaves. We'll pretend it's fall so that they've turned golden. 120 is the product of these numbers. Typically what we do is we write these numbers in order, and if a number occurs more than one time, then we use an exponential form. So I see 2 times 2 times 2. That's 2 to the third times 3 times 5. That is the prime factorization of 120. Now, the factor tree is kind of neat because it's easy to see. It's sort of free-flowing. That may not be the only way that you see 120 factoring. So I might come up with a different tree depending on how I look at it. And the tree will look different, but when you get all the way down to the leaves at the ends of the branches, they'll turn out to be the same. For example, I might have thought of this as 40 times 3. That's a possibility. 3 is already prime, so that branch of the tree will not branch any farther. But the 40, maybe 4 times 10. 4 is 2 times 2. 10 is 2 times 5. Look at the numbers. The leaves, the numbers at the ends of the branches of the tree. And we again get 2 to the third times 3 times 5. Let me just check back. Yep, that's what we got before. So I think that's good. Now there's a second method for factoring or finding prime factorizations that is also available. This is a more methodical approach. And some people like one method and some people like the other. In the methodical approach, you start with the number you're looking at. It was 120. And rather than just thinking about any two numbers that multiply to give you 120, you always start with the lowest prime number. So you pick the first available, the smallest prime number, and what you do is a little division problem, and you ask yourself, does 2 divide into 120? It does. You get 60. And then you check 2 again. You don't give up on a number until you're sure that it no longer will divide into what's left. So you ask yourself again, does 2 divide into 60? And it does. It goes 30 times. And then you say, well, let's not give up on it. Does 2 divide into 30 again? Yep, it goes 15 times. And actually what you should say is, does 2 divide into 15 evenly with no remainder? And suddenly you realize that 2 will no longer work. So when that happens, what you do is you just think about your list of primes and you go to the next prime number on the list. Next prime number on the list would be 3. 3 divides into 15 5 times, and you stop when the final quotient you get is itself a prime. Now, this is appealing to some people because it's very, very methodical. You don't have that sort of freewheeling, oh, let me try to think of 2 numbers that give me a product of 120. You just start with the lowest prime and you work your way up. And then what you do at the end is you look at all of these numbers that you divided by and the final quotient, and the factorization is the product of all those numbers. And using exponential form, that's going to be 2 to the third times 3 times 5. And guess what? That is the same answer that we got with this factor tree and with that factor tree. So 2 separate methods that you can use to find the prime factorization of a number. Hope that made sense.